Okay, and the last one for today is a little bit of trig identity trig equations. So we've got to somehow prove that sine theta over 1 minus cosine theta, that's 1 over sine theta, that all is equivalent to 1 over tan theta. And I guess when you look at these trig identities, the first thing you do is kind of look at both sides and try and think, oh, okay, what might be a good way to get this close to looking like this? So we know that 1 over tan theta, you can make some notes to yourself, I suppose, on the side that might help you. So we know that 1 over tan theta is going to be the same as cosine theta over sine theta. So normally it's sine theta over cosine theta equals tan theta. But this is 1 over tan theta, so which means it's been reciprocated. So we know that we're after something like this on the left-hand side. So we do still want a sine and a cosine in there, but we want it to be upside down like that. So we go back over here and we think, okay, is there anything that we could do with this to kind of make life easier for ourselves? And I guess one thing that pretty much we do when we see fractions when we're trying to do trig identities is most of the time it works to combine those two together. So let's try that. So if I'm combining these two fractions together, the idea is I'm going to multiply denominators to get a common denominator. So I'm going to multiply the numerator and denominator by sine theta here, and the numerator and denominator by 1 minus cosine theta here. So I'm going to end up with sine squared theta minus 1 minus cosine theta all over 1 minus cosine theta sine theta. So multiplying the denominators together. Let's just make that all equivalent to 1 over tan theta. And you're thinking, well, maybe that's not so helpful, because what I've just done, I've introduced the sine squared theta term, which we know is not what we want. We want cosine theta over sine theta. But what I could do is replace the sine squared theta with 1 minus cosine squared, because we do know also with this other identity that we've got, which is that sine squared x plus cosine squared x equals 1. And why I might want to do that in this case is that I can, if I think kind of ahead, what I need is just sine theta on the bottom. And I've got this 1 minus cosine theta. Somehow I want to cancel it out somehow. I need it to be a factor at the top. If I replace the sine squared theta by 1 minus cosine squared theta, I'm going to have this like quadratic-y, cosine-y thing going on, which I think should enable me to get like a factor that I can cancel out. So I'm kind of thinking ahead. So if I replace the sine squared theta with 1 minus cosine squared theta, leave that on the left hand side, put that subtraction sign between, put the 1 minus cosine theta there, and leave this down here. Okay, so it's still not tied up yet, but now I can probably do something with this. So I'm just going to move this up so I've got a bit more space here for me. There we go. Okay, so let's tidy up the top of this. So if I look through this, I've got 1 minus 1, so that's going to be 0. And I'm going to get, oops, I think it's negative cosine squared. Let's do that. And I'm going to get plus cosine theta here, negative cosine theta there. And that's still all over minus cosine theta sine theta. Cool. Let's just move that up some more again. Like that. Okay, cool. Now if I factorise that, I can take cosine squared, or cosine, out as a factor. I'm going to get minus cosine plus 1 there, all over 1 minus cosine theta sine theta, 1 over tan theta. And hopefully at this stage you're like, yay, we've done it. Because this baby here is the same as this baby here. Like if I just reverse that around, it'll be 1 minus cosine theta. That's 1 minus cosine theta. They're factors. So what's really important here is if I want to divide through and cancel things out, they've got to be factors. So that's cosine theta times all of this. And that's all of this times sine theta. So I can cancel those out. And I've just shown that cosine theta over sine theta is equivalent to 1 over tan theta. So let's just write that out. Move it up again. Oops. Oh. So we get 1 over tan theta is equivalent obviously to 1 over tan theta. Okay, so let's move that all out of the way. And here we go. Let's solve the second part of this one, which is really easy at this point. The cool thing about this is because you've already shown that all of that equals 1 over tan theta, you can just take that straight away. So basically we've already got 1 over tan theta equals equivalent to 4 tan theta is what we're trying to solve for ourselves. So let's make that one equals 4 tan squared theta, which means that tan squared theta equals 1/4, which means that tan theta equals plus or minus. Don't forget the plus or minus part here, because we are square rooting it ourselves. So if it was 25, the square root of 25 would be plus or minus 5. Here the square root of 1/4 is plus or minus a half. Okay, so we're trying to solve tan theta plus or minus a half. We go back here and we see that our domain is in degrees, so that tells us our answer will be in degrees. And we also see that it's between 0 and 180, so we're looking at 0 and 180 there. So there we go, that's what we're looking at. And we're looking at plus or minus a half, so a half there or negative a half there. So we've got two answers that we're after, that one and that one. So if I plug those onto the calculator and I do inverse tan of a half, I get 26.6 degrees. Remember, for angles in degrees, we're always round to 1 dp. And to get the other answer, I'm just going to take 26.6 degrees away from 180. So I get 153.4 degrees. And we're done.